species identification guides, this kind of books. And quickly, we are like 200 employees, and we have 25 years of experience. So we work for private sector, but also public sector, funding agencies, and sometimes NGOs. And me, so I have a background in fishery science, and I worked also on the elephant seals, on the movement ecology on elephant seals. So yeah, I stress that I am not at all a bad specialist. So I'm probably bad statisticians and a bad ecologist, because I try to work on both aspects. But I do have some understandings of both domains, and so I try to make a bridge on between statistics and ecology in engineering office, which is a challenge, and also between the private sector and academic research. And so my goal here is to, within the Ecodep project, is to explain our needs and propose some data, if and to potentially engage it in working relationships if anybody is interested by the same topics as we do. So the bat conservation context. So what the bats are the only flying mammals. It's a very large group of mammals, the second largest after rodents. They're generally very small, like weight as little as 2 grams, but the biggest can weigh a lot more. They're social animals, and they have a very wide, very different ecology, with different roosting sites from trees or buildings, caves, and different diets. So in Europe, all bats eat insects, but they can feed on amphibians, fish, bloods, flowers, fruits, and so on. And some species are migratory in Europe, and some are not. So yes, quite a large, huge difference in their ecology. A famous property of the bats is their echolocation as well, and it's very specific to the species, and they also have, according to their sonar features and diets, very different wing morphologies that are adapted to feed, to forage on large prey or small prey, and in different environments like forest or higher altitude area. So the bat in France, there's a lot actually, 34 species, or 33 according to people, but on the 45 in Europe, because there are quite a few different climates, and the richest area in France is the Mediterranean area, but as a global pattern, the bats are more, there is more bats diversity when uh, the, the latitudes get lower, so near the equator. So this is on the right some example of bats with different shapes and morphologies. And so the history of bats in Europe is that they had population had a dramatic decline, but now the conservation is more has raised, and the population has stabilized. but many species remained threatened, and so they are all protected in Europe. So here, one in France on the right, there's one species that is critically endangered, but 3 of them are still very vulnerable. So there are many possible threats to bats, like the decreasing insect imbalance, light pollution, the changes in agricultural landscapes, or in the building styles, like less wood, less roosting sites. But something I want to talk more today is the direct kills by wind turbines. So highways and wind turbines are the main cause of human-related death, and all species are concerned with this death. It is a concern because the bats are the key demographic strategy. It means that they're long-lived, and they have a low reproductive multiplication rates, and invest a lot of time and energy in the offspring survival. So these characteristics make them very sensitive to, vulnerable to excess mortality, and it means that population are also slow to recover, and as quite some population are still at low levels, they're also very sensitive to natural stochasticity in the natural stochasticity. So this is an issue, and moreover, the wind energy production is rapidly rising in all Europe and worldwide. So it has different kind of effects, direct or more indirect. And I will more now talk about the direct mortality. So when the bats collide with the blades of the turbines, and also barotraumas that are death caused by pressure, high pressure differences that made the lung explodes when the animals go too close from a rapidly rotating blade. So what do we do about it? So there's two kinds of work we do to reduce this. So first thing is the baseline study. So it's for wind farms, it's mandatory in France. So the goal here is to assess which species are present, and how important is the area for the species. And so then to implement what is called the mitigation hierarchy, that is to avoid the impacts when it's possible by making planning decisions, relevant planning decisions. Then when the impact cannot be avoided, then you try to reduce these impacts. So you can do as well some design choices, or be extra careful when you build the projects. And eventually, if the remaining impacts must be compensated for that, so that offsets and here you've got an example with forest restoration. So what our now presents a few type of question we are interested in. So the first problem is related to the way we make the monitoring of bats. So we use echolocation, and passive acoustic monitoring. But obviously, an acoustic cue, such as a bat call, is not an individual, so it makes difficult to really know the abundance of the different species, but this information is very important for the manager. So why is that difficult? So because acoustic cues production rates is often unknowns, and also the detection range is so it's ultrasounds, so detection range can vary a lot between species. So you can see on the right, can go from a few meters for the shortest detection range to more than to 100 meters. So the detection of the different species is very different. And acoustic monitoring is passive acoustic monitoring is also very sensitive to noise levels. So what we are trying to do to help the managers to rank the abundance of the species, and to really assess how important is a given area for a species, is to just use very simply our database of data and to look at the quantize. So is it a top site, or is it a low bottom site in terms of quantize? But we know that this can have is subject to sampling issues, because the database we have is observational data. So we have data where there was a project before, and the projects, especially wind turbine projects, are not randomly chosen. And another approach that we sometimes use, but more in the research and development context, because it's a bit heavy, is especially explicit capture recapture. So we use the microphone as a proximity detectors, and um, and uh, uh, and this allow us to estimate the detection range, and so the actual number of call that was emitted by the bats, but it does not allow to have really a number of individuals. So these are very big limitation and difficulty for the study of bats, but at the same time, as it's nocturnal and very small animals, passive acoustic monitoring is the vastly the, the only way to study and to get a large amount of data for the species. A second family of problem is the interpretation of mortality data. So once a wind farm has been established, you must monitor the mortality. So there are very specific protocols where observers look for carcasses of birds and bats at around the turbines. But what does a carcass represents in terms of actual number of bats that were killed? It's not an easy question, because there's a lot of negative bias. So, for example, a bat that was killed and can fall far away from the turbine. If it falls close and can be found, because within the study area, it can be taken by a fox or a predator. It can be hidden by some I don't know the word. Anyway, it can be taken away, so and never found. And even if it stays, then observer looking for a carcass may not find it. So a few number of carcass is actually found, and there is a large uncertainty and difficulty to correctly estimate the number of fatalities. And but still, there's a lot of work on that, and protocol are well established, but it's still difficult to get accurate estimates. So that's an issue. And the second aspect that is maybe of interest to demography, people studying demography here, is the viability analysis. So when we have an estimate of the number of fatalities, it's difficult to say how this will exactly impact the bats. So we need to understand how, because of the low fecundity, the low reproductive rate, and the key demographic strategy, what will be the long-term and consequences on the population? Will they be able to survive, to expand even, or will they decline and possibly go extinct? So this is what really matters for the management of and the conservation of bats. But paradoxically, it's very difficult to know. And I think that's a very interesting issue that can be studied with data, or even on a simulation-based approach. It can be very interesting. So that's two subjects I think may interest you. A third problem regarding bats and collision risk. So there are two aspects actually. During the baseline study and the early planning phase, it's interesting to understand the bat movements. So we do acoustic tracking using several microphones. We use the time difference of arrival with something we call the sonospot we developed to infer the trajectories, and then identify the most precisely as possible the area with the collision risk. And at a larger scale, it would be interesting. We haven't done it yet. Sorry. To have distribution models for the different species, in order to have prior information and to use it in the very early stage of the project, because when it's very early, then you can avoid easily, and that is the most efficient way to reduce the impacts on the environment. And in exploitation phase, once the turbines are operational, one solution to reduce the impact is to use a curtailment algorithm. That is to say that anytime you think that bat abundance will be bat activity around the turbine will be important, you stop the rotation of the blades to avoid collisions and barotraumas. So this is currently used, but the algorithm that exists may be too simplistic. So, for example, the collision are considered to be strictly proportional to the acoustic activity, but it may be more complex because the behavior or acoustic activity may vary according to the um, the various environmental parameters and to the blade rotation speed, for example. Uh, Generally, the algorithm used just simple thresholds, so there's no real uh, um, modeling modeling methodology um, implied. The species are all mixed, but we know that a lot of bats have a ecology very different with different preferences and various flying height. So some are migratory, but so they have very high peaks of activity in the year, and but it is kind of extreme events, so difficult to predict. And the algorithm are based on the real-time data, like on the wind temperature, but do no use larger scale information, which in general can bring more robust prediction. So this is a time series problem, and I believe there is a lot of there are a lot of experts here. So I hope this is a subject we could potentially work on to avoid bad fatalities and facilitate the spread of this algorithm in the wind farms. And the last problem, this is more something for the uh, machine learning community. So I don't think this is the case here, but we do not know. This is the question of processing the species classification, classification from acoustic data, because as we use acoustic detectors, there is a large volume of data, and somewhere we have to be able to automatically process this data to uh, to uh, to to be efficient and to yeah, to be to be efficient, simply put. And at the same time, we do need accurate species classification results, and we need to know uncertainty about these results to help the naturalist experts to focus on the manual identification of the rarest species and the relevant data. So now at Ecodep, we developed this outil that is called Sonokiro, that is that try to do that the best way as possible, but it's based on random forest. But yeah, we would be very interested in the insight of some people there that would be interested by this machine learning problem. So to conclude, I like to explain a bit what data we could share to work on this, or maybe your own ideas of interesting question. So the typical setup for our passive monitoring study is to use at least two microphones vertically like that, or sometimes four microphones on a pole or a mast, which by then calculating the time difference of arrival to know what the if the bats are flying higher than the median height or lower, and so have an idea of if its behavior increase or attenuate the collision risk with the relatively to the blades. Sorry. um, so yes, the spatial temporal coverage of our dataset. So it's mainly in France that we had gathered a dense enough network of sites. Um, so here you see it's actually clusters of data. Each pixels here with data is in black. Is the small semi-transparent black squares. So it's quite a large data set, especially with given the fact that we try to have the same material, the same microphone, the same analytical technique, processing methods to have a better comparison between our sites. And we've seen that it's very important, but at the same time, it's observational data, so it's only where projects of wind farms or roads have been conducted. Data sets are typically a year long. Sometimes the sites were monitored for 2-3 years. And monitoring is focused on the April-October period, where the bats are the more active. So, but we also have a few sites with data outside this interval. So there's auxiliary data, like the local weather data. We can look for the proximity for nearby roosting sites, which increase the risk. We look at the land cover, like agricultural landscape, forest, water, habitat that can be used by bats for foraging. And the mortality monitoring data, so the different kind of data we collect for these studies are we do persistence tests to see how long the carcass remain in the study area. We estimate the searching efficiency of the observers, and of course we look for carcasses and record the location, as well as the land cover and vegetation height where they was found. And to complete this data set, some external database may be used as well, such as a citizen science program or yeah, mainly a citizen science program. So I hope this was interesting for you, and I thank you for your attention, and thank you.
Thank you, Yves. Thank you very much for the talk and for the. I hope that that there is
Sure.
some way of collaborating on such interesting program through I don't know, maybe some master or PhD level students. It would be a very interesting aim, I think. Okay,
Thank you.
so so I wish to thank you as well as all the speakers of the day. Uh, I should say that in my presentation I did a small mistake, and if you go to the corrected presentation, then it includes the right schedule. So it is online, and every the information which are online are fine. So thank you very much for everyone, and have a good evening or a good day depending on where you are. So bye bye, and see you tomorrow morning, hopefully.
Thank you.